Hi, today we're going to look at a word problem that can be solved using trigonometry. In the big windstorm last week, the rope on the school flagpole broke and blew away. The custodian needs to figure out how long a rope he needs in order to replace it, but the man lift is out for repairs, so he can't get to the top of the flagpole to do it. Mr. Lanfer has an idea. He goes out to the flagpole on a sunny day with a tape rule and a protractor, and he measures the length of the shadow of the flagpole and uses the protractor to measure the angle the sun makes with the ground. He finds that the shadow is 47 feet long and the angle of the sun is 32 degrees. How can he find the length of the flagpole? Well, the first thing you should always do when you're faced with a word problem, especially when it starts talking about shapes and things, is draw a picture. So we have the flagpole, and it's okay to make the assumption that the flagpole is perpendicular to the ground. So here's the flagpole. And here's the end of the flagpole's shadow. So I'll call that side S for the shadow. And I'll call this H for the height of the flagpole. Now, Mr. Lanfer measured this and found this to be 47 feet. And then he measured the angle of the sun. Well, the way you would measure that angle, the sun would be shining over the top of the flagpole down to the point where the shadow is on the ground. So this would be the angle that Mr. Lanfer would have measured. And it's a 32-degree angle. So we have a right triangle with a 32-degree angle. We know one of its sides, and we need to find one of its other sides. Now, this is not like solving the triangle because we don't have to find all of the parts. We just need to find one. So we want to look at the situation we have. We have this angle is 32 degrees. Here's the right angle. We know the side, the leg, that is adjacent to this angle. So this would be the adjacent leg. We're trying to find not the hypotenuse, but the leg that is opposite the 32-degree angle. So we think about our trigonometry. Remember, we learned there was an acronym, SOHCAHTOA, that we can use to help us remember which trig function uses which sides of the right triangle. We want one that uses opposite and adjacent. Right there is opposite and adjacent, and it goes with the T for tangent. So when we write our equation, we're going to use the tangent of our angle. Remember, a trig function always needs an angle to act upon. And then we can say that that is equal to the length of the opposite side, which is H, over the length of the adjacent side, which is 47. So now we want to solve to get H by itself. Please remember, don't put this into the calculator before you solve for H. Just treat it like a variable and carry it along in the problem. So to get H by itself, I need to multiply by 47 on both sides of the equation. So that gives me 47 times the tangent of 32 degrees equals H. Well, 32 degrees isn't an angle that we know the tangent of, so we can use a calculator. Remember, when you're going to do trigonometry on your calculator, you need to check your mode first to make sure that it is set in degrees, and mine is. So I get out of that, and now I'm going to do the tangent of 47 times the tangent of 32 degrees. And I get 29.369 That would be rounded to 3 decimal places because this 8 in the 4th place would make the 8 round up to 9. So that's h is 29.369 feet. So the height of the flagpole is 29.369 feet. Now, if we were really going to try to find the length of the rope, you know that the rope runs on a pulley system, so you'd have to go all the way to the top of the flagpole and then all the way back down. But it doesn't necessarily go all the way to the ground because the place where the pulley is isn't usually clear down at the ground. So to find out how much rope he'd have to buy, you'd want to double this. So it's almost 30 feet, so he should buy about 60 feet of rope. Or I would say he should buy 60 feet of rope. That way he'll have some extra in case. Okay? So that's an example of using trigonometry to solve a problem.